Hello everyone, thanks for tuning into today's video. We're going to do something a bit different with today's video. We're not going to look at any models, and we're not going to really look at an outlook as such. We're going to look at the spring of 2013 in terms of the Central England temperature that we had for the spring of 2013, very cold spring. And we're going to compare it with past cold springs and then look at what that could mean going forward in towards the summer and the coming winter, using the Central England Temperature Index. There's quite a stark sort of pattern emerging. If you have a look at the numbers, we're going to crunch the numbers. And I said, it's quite interesting patterns emerging, actually, as we look ahead towards the summer and the winter, based on the Central England temperature for the spring of 2013. So really this video is going to be a numbers game, and I hope you find it interesting. It's certainly something a bit different for me. It's quite complicated, so I hope I explain it alright. We'll go along. As we go along, I'll try to explain it in terms of simple terms that you'll understand, but it is quite a difficult concept, so we'll see how we get on with it. Now, before I get on with this video, I've got to do a couple of things. I've got to first of all say about the advertising. There's keyword ads on all my pages at GarethWebBiz.com. Some of the words will be illuminated green, and those green words display links. If you roll your cursor over them, click on the words and you'll go through to the advertiser's website. By doing it, you're supporting the website, and it's just something I'm experimenting with, something I'm trying out. Always looking to try out new things with website, and so I'm just experimenting with this, so see what you think to it. Also, I've got to say hello and thanks for watching to two of my youngest fans, Christian and Daniel. I've been informed that they are avid followers of my weather videos at GarethWebBiz.com. They watch with their dad, Gareth. Hi guys, thanks for tuning in to today's video, and thanks for watching all of my videos that you've been looking at. Hope you've been enjoying them. I hope you carry on enjoying them. Hope you keep coming back to the website and enjoying what I'm doing. Thanks very much for supporting the website, guys. And just want to say this: if GarethWebBiz.com and my videos prove an inspiration for you to go on and become a meteorologist when you grow up and you end up on the BBC doing weather forecasts, just remember where your inspiration came from, and you'll still be able to find me here, hopefully doing these weather videos. So come back and I'll give you my address. You can send a check to me for being your inspiration. But in all seriousness, thank you very much, guys, for watching, and hope you continue to enjoy the videos. Thanks very much, Gareth and Daniel and Christian. Thanks very much to the three of you. So yeah, we're going to have a look at the Central England temperature. Just explain what the Central England temperature is first of all before we go on any further. I better just say what Central England temperature is all about. It's an index of temperatures for every single month for every single year, going back to the year of 1659. So it's basically the oldest and most reliable temperature index anywhere in the world. I don't think there's anywhere in the world that has an index of temperature quite as extensive or as consistent or as long lasting as the Central England temperature. It's a tremendously long statistical series of years, I say going right way back to 1659. Phenomenal sort of information is contained within it, and you can look at lots of this at Hadley. You can find the link to Central England temperature at the Met Office at Hadley from my links page. I'm not using it for today's video, but yeah, you'll be able to find the Central England temperature going right way back to 1659 on my links page to see which years were the hottest and which were the warmest. Hint, the warmest years have tended to be very, very recently, whereas the coldest years have tended to be much longer ago, in some cases hundreds of years ago. The coldest year actually is 1740. So what we're going to do with today's video is we're going to look at very cold springs that have had a deviation of 1 Celsius below their rolling 30-year average. Should I explain where the idea for this came from? It came from the WeatherOutlook.com forum. If you've never been to WeatherOutlook.com forum, do check it out. It's a wonderful place. I spend many a happy hour on the forum at WeatherOutlook.com. And the keeper of the Central England temperature records, really, the guru who knows all about Central England temperature records at Weather Outlook, is the poster, the user Global Warming. And Global Warming came up with a table that had the very cold spring of 2013 compared with very cold springs from the past. Using that table was then able to project what may happen through the summer and the winter in terms of the temperatures compared to what happened during the spring. Now, there was a slight flaw with that table because it was comparing past springs, then the subsequent winters and summers, the past seasons. It was comparing them to the 71 to 2000 average. And of course, the 71 to 2000 average encompasses all those warmer years through the 1980s and 1990s. So perhaps not that reliable to compare that 30-year average to, say, the average of 200 years ago, because it's a much colder time. So any winters or springs or summers from, say, 1700 and something compared to the 71 to 2000 average would probably look really cold, but back in the 1700s and something probably wouldn't be that cold. That's the idea I'm trying to get at. So the 71 to 2000 average probably not quite right to compare seasons from hundreds of years ago, which was a much colder time. So the best way of doing it is the way that the another poster at the Weather Outlook Forum, Darren S, has come up with, and that is to compare these seasons to their own 30-year rolling average. So, for instance, 2013, the spring of 2013, here is being compared to the period from 1984, the 30-year rolling average from 1984 to 2013. 1962 is another year that's got a very cold spring, and that year would be compared to 1933 to 1962, the 30-year average for 1962, and so on, going right way back through the Central England Temperature Index. So we're not comparing these to a modern sort of 30-year average, except for 2013, of course, which is compared to 84 to 2013. We're comparing this to each individual year's and season's rolling 30-year average. And I think that's a slightly better way of doing things, because it means that once we get back towards the 1800s, the 1700s, we're using 30-year averages that are in keeping with that particular time period. We're not skewering things and make things look colder than they should be, or they were, by using a warmer average like what we currently are in. Okay, so that's all explained. The other thing I've got to explain is the years we're using for this. We've got 33 years that we're using, 33 springs that had anomalies compared to their 30-year averages of 1 Celsius or more below average. And the first thing we're going to look at is 2013, just to put 2013 into context with its average. So I'll just quickly highlight it. Here is 2013, and it has a Central England temperature of 6.9 for the spring of 2013, which is an anomaly of minus 2.1. And that's a really big anomaly, actually. There aren't many years that have an anomaly as big as that set against the rolling 30-year average. There aren't many years that go down to 2 degrees or more below the rolling 30-year average of those years. And in fact, you have to go right the way back to the spring of 1837. There it is there, to find an anomaly that the year that had a bigger anomaly than, than 2013. And that had an anomaly of 2.6, the biggest out of these 33 years. So yes, a really unusual spring has occurred for the British Isles. You don't see it very often in this table, that you have a spring with such a big anomaly compared to its rolling 30-year average. So that's quite surprising. I'm quite surprised at that, but there was such a big anomaly for the spring of 2013. Of course, much of it is made up from the very cold March, but nevertheless, that is really quite surprising. Now, the years that had these cold springs, quite interesting as well, just to quickly talk about that, because in the 20th century we actually had 6 springs maybe surprisingly that it would be that high, there was 6 springs in the 20th century that had anomalies more than 1 degree or greater than 1 degree, set against the rolling 30-year averages. But in the 19th century, so going from 1800 to 1899, we actually have 14 springs that have cold anomalies of more than 1 degree Celsius. The 18th century, surprisingly again, I'm quite surprised by this, has 9 springs. So there's more cold springs in the 19th century than there is in the 18th century. Even though the 18th century is going back more towards Little Ice Age, and by the 19th century it was coming out of the Little Ice Age, nevertheless, there's more cold springs in the 19th century than there is in the 18th century. I'm quite surprised about that. And the 17th century, it's hard to say much about that because there's only 3 years listed in this, from 1659 to 1699. We've only got 3 springs, so it's hard to say how many cold springs there were through the 17th century. But I would guess that it probably doesn't come out as much as what we had in the 19th century. So quite interesting statistics there from all of that. So let's go forward now, start to think about what all this could mean for our winter and our summer, and we're going to deal with summer first of all. So the first thing to say is that these are the years here that we've got listed on this table. These are the Central England temperatures for the springs of those years. These are the Central England temperatures for the summers of those years, and then these are the Central England temperatures for the winter of those years. So each season has its own individual Central England temperature average through that particular season. And then these tables here are how those seasons compare to the rolling 30-year average of that period. So for instance, we've got 1962 there, the very cold spring of 1962 listed there, and then we've got the summer of 1962 listed there, and the winter of 62-63, severely cold winter, of course. And then here we have the averages that those seasons are compared to the 33 to 62 average. So the spring Central England temperature should have been 8.6 in 1962. It was actually 6.9. The winter average of 62-63 should have been 3.9, and it was actually minus 0.3. So there are all the numbers, and you can find all of this data out for yourself, as I say, at the Hadley Central England Temperature website. You can see all of these seasons, all of these numbers will be listed, except for the averages. The rolling 30-year averages aren't listed. They've been worked out by my good friend Darren S. I'm sure he's watching this video, and thanks very much, Darren, for supplying me with this league table. The averages have been worked out, but these seasonal CETs can be found at the Met Office website. So let's just think about how this is going to play out as we go forward. And the first season I want to deal with is the summer. These are the anomalies compared to the 30-year averages of those summers. And what's quite apparent, and very apparent really, with this is that with these cold springs, there's very few summers going forward that have anomalies greater than 0.5 above average. I've chosen 0.5 as the starting point really for an above average summer, because anything under that is very close to average. And again, it'll be the same idea for below average. We're going to be looking at years that have summers and winters 0.5 of a degree below average. Reason I say is anything that's within 0.0 to 0.5 is really around the average, and give or take a few tenths of a degree. So I think it's important that we have a threshold here for looking at summers and winters that were above and below average, above the 0.5 Celsius mark. So yes, any summer here that is more than 0.5 below average really, after these cold springs, really is very much in the minimum. And we actually find that there's only 6 summers out of these 33 years that have summers with a temperature deviation greater than 0.5. So we've got one there in 1701, we've got another one going down into 1837, another one going down into 1887, another one going down into 1955. There really isn't very many of them though, and the point here with this is another one there in 1941. But the point really with this is that there aren't many. There's only 6 of them out of the 33 that have warm summers, and what's even more apparent is that very many of the summers that do come out more than 0.5 above average, many of them are just a little bit above average, so most of them are around 0.9, 0.9, 1.0, 0.5. There's only really this one really warm summer, or this isn't really warm, it's not it's like 1.5 or 2 degrees above average, it's 1.4 degrees above average in 1701. That's a pretty warm summer, but many of these summers really are struggling to get anywhere above average. Even ones that come out a little bit above average, they're not really warm, they're not really strong and hot summers. Now the summers that come out below average, much greater number, 14 out of the 33 come out below average. Again, we're using 0.5 Celsius below average as our starting point. And there's some really cold summers in with those 14s as well. Say 1695, which has a deviation of 1.8 below average, 1812, 1.5, 1816, 1.9, and so on. There's a much greater chance, or I should say not only is there a much greater chance that the summer statistically will come out below average, there's also a much greater chance that it will be greatly below average. Whereas even if the summer does come out above average, and there is a chance statistically that the summer could come out above average, it's very, very unlikely that it's going to come out well above average. So that's quite a stark sort of statistics those are for the summer. Quite surprised that it would be that evident, but certainly it does look that evident that if the summer comes out above average, it's not likely to be much above average, and it's much more likely to come out below average, and possibly well below average as well. Great chance of it being well below average than well above average. So that's quite interesting. Now we're going to go forward, have a look at the winter next, and the winter is a little bit more interesting, or not more interesting, but the division between the statistics for winter are quite a bit greater really than for the summer, because we see that whilst the actual numbers for above and below average are very similar, we've got 7 years that are above average, 7 years out of the 33 that are more than 0.5 degrees above average, but for below average we've got 12 years that are more than 0.5 degrees below average. So very similar. For summer it was 6 and 14, for winter it's 7 and 12, so quite a similar sort of split there for the winter. But what's interesting is that the years that do come out above average, those 7 that come out above average, many of them are quite well above average. So we've got one there at 1.8 above average, one at 2.2, another at 2.1, another at 1.5. Much greater chance that if the summer comes out, that if the winter comes out above average, it'll come out well above average than is the case in summer. In summer, if it comes out above average, there's very, very slim chances that it'll come out well above average. But in winter, if it comes out above average, there's a good chance that it'll come out well above average. But statistically, and the statistics with this are interesting, that we're more likely, whilst we could come out above average and come out well above average, we are more likely, the statistics say, to come out below average. And again, there's some really strongly below average years in with this: -1 below average, -2.1 below average, -2 below average, and of course we've got 62, 63 in with this, the severe freeze up of 62, 63, which comes out 4.2 below average, a huge sort of deviation from the rolling 30-year average. So the statistics, as I say, are quite stark on this, quite interesting. And the idea really, I think, as we're going forward, is that if you look at the numbers for the spring of 2013 and you was to compare it to all those past years within the index, the other 32, it's highly likely statistically that the summer is going to come out below average. This summer is going to be a cool summer, could be very cool summer, And if it comes out above average, there is a chance it could come out to above average, a slim chance, but it's there. If it comes out above average, it's very likely not to be much above average. It's very, very unlikely we're going to have a hot summer. Can't be ruled out, but based on this, very unlikely to be a hot summer. So that's quite a stark idea for summer. For winter, the split is much more diverse because whilst statistically it's more likely that for winter we're going to come out cooler than average, there is still the chance that we can come out above average. And it's interesting because if we do come out above average for winter, it's very likely that we're going to be well above average. It could be a really warm winter or a really mild winter if we come out above average. But the statistics do say, based on this methodology, and it's just looking at the numbers really, and maybe you can bend numbers any way you want, we do say with this methodology that for winter it is quite likely we're going to have another cold winter following on from this very cold spring. Now, how seriously you can take this, I'm not at all sure really. It's just playing around with numbers. It's a bit of fun for a Sunday, but don't take it too seriously. I hope you found the video interesting though. That's it for now. Thanks for watching.